Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering 5.1, which is talking about graphing square root functions. This unit's a little bit of a catch-all. It goes sort of all over the place, but thankfully these first couple lessons should be fairly simple, and they should look very familiar to you from previous units that we've done. So let's go ahead and get started. For this, because we're doing this online, we're going to be using Desmos. So if you go into Desmos here, we're going to start with the parent square root function, which is y or f of x equals square root of x. And so you can kind of get a look at what this shape is. You are asked to identify the domain and range, just like any other function family that we first introduced. So if I look here, the domain and range of this function are all of the positive real numbers. You could also write that in function notation, going from 0 to infinity, and that's true for the domain and range. The reason for that is when we take a square root, it has to be a positive number, right? Otherwise, we end up with an imaginary number. So your domain and range for this section is going to be a set of all positive real numbers, or you can do your set notation 0, infinity. If you're writing it in set notation, remember you do square brackets to be inclusive, and then infinity, like so. So that's how you would write your domain and range. Then, if you have looked at the PowerPoint lesson, you'll see a sort of expanded form for the function that looks a little bit something like this. This should look familiar to you. This is the parent function written out, including your other variables a, h, and k. If you recall from previous assignments, we have something similar when we look at quadratic functions from Integrated Math 2, which looks like this. We have the same thing when we look at absolute value functions in Integrated Math 1. So all of these have the same variables, a, h, and k, other than, of course, your input and output, and they're all doing the same thing. Your a is going to do the same thing, your h is going to do the same thing, your k is going to do the same thing. So very simply in this assignment, you'll be given your parent function and asked, okay, well, how do I move this up? How do I move this down? And you can add the sliders here in Desmos if you want to play with it. But remember that k is what moved the function up and down for quadratics, for absolute value functions, for any function family that looks similar to this, it's the same process. So if I want to move the graph up 1, it's square root of x, and then on the outside, plus 1. If I want to move it up 3, I do plus 3. And vice versa. If I want to move this down 1, it's minus 1. Down 2 is minus 2. So on and so forth. So in every function family, that k is moving it up and down. I'm going over this very quickly, and I'm not going to elaborate on this too much or give too many examples in this video because you guys have already seen a, h, and k now. This is the nth number of videos that we've seen with these same variables. So I'm hoping this is an easy lesson for you. Same thing with h. H is going to move it left or right, just like any other function family. But remember, because the formula is x minus h, it's kind of backwards. We're used to thinking of minus on the x-axis being to the left and plus on the x-axis being to the right. While that is true, because I have a negative sign in my formula, it switches the direction. So if I want to move it, let's say, to the left 3 spaces, I would need a plus 3 inside the radical sign. If I want to move it plus 5 to the left, then I would have a plus 5 in the equation. And vice versa. If I want to move it to the right, then it's going to be a minus. So x minus 1 radical moves it to the right. If I want to move it 6 spaces to the right, then it'd be radical x minus 6. That's the majority of your assignment. You're also asked to comment on what the a value does. So if I'm looking at y equals radical x versus 2 radical x, 3 radical x, 4 radical x. Remember that a value is increasing the speed at which the graph is increasing. So any a value that's greater than 1 is going to cause it to be more steep, if you will, and vice versa. If I have a value that is less than 1, like let's say 1/2 or 1/3 or 1/4, then it's decreasing more slowly. One last thing here, just like other previous sections, I might give you, and of course, you know, with the video going, it's going to show you what it is, but I might hide this on a test. Let's say show you something like this and ask you to comment on, well, what's the equation of this graph? Or what's one possible equation for this graph? So you're looking for where the graph has shifted from the origin. So we start at 0, 0 with the parent function. This graph got shifted 1 to the right. Therefore, your answer would be y equals radical x minus 1. And then change it again, something like, let's say, radical x plus 3. You wouldn't have the graph up here, or the equation rather, but if you're looking at the graph, and the question is, what's the equation of this function? It is square root. You should recognize that shape. And then because it's been shifted up 3, your answer would be y equals radical x plus 3. That's all for this section, guys. If you have any questions, please reach out to me or attend office hours. Otherwise, have a good day, and I will talk to you soon. Bye.